All right. Good morning, everyone. Thank you all for joining us this morning. I am going to give it another minute or so and let some of our students that are logging on get logged on and get situated before we start the presentation. So just sit tight and we will start shortly. Again, thank you for joining us this morning. We'll get started in a moment. All right. We will go ahead and begin. Once again, good morning. My name is Kevin Henry. I am the marketing strategist for the Viterbi School of Engineering, specifically on the graduate recruitment and admission team here within Viterbi. And I'd like to start off by saying congratulations on your admission to the University of Southern California, as well as the Viterbi School of Engineering, and welcome, officially welcome to the Trojan family. All right. This workshop, this presentation is really designed for you to get more information as we now know that you are all trying to decide if Viterbi, if USC is going to be a great fit for you. And so we have a lot of my colleagues on the call this morning that are going to share a wealth of information for all of you and answer all of your questions as you guys are now in the process of making that decision. While we go through the presentation, I want to cover a few nuts and bolts. The presentation is being recorded. So if there's any information that we go over that you either missed, or if there's a QR code or a link or something you want to go back and refer to, this will be uploaded to the website at the end of the day today, and you'll be able to access it and kind of refresh. If there's conversations that you want to go back to, you can go back and access that on our website, and you'll have the link to do that. So it is being recorded. Also, we ask, as far as like the nuts and bolts go, if you have questions throughout the course of the webinar, please type those in the Q&A box. You should see it on the bottom that says Q&A. Type your questions in there. We'll be able to answer some of those questions in real time. We'll also make sure we get to those questions at the end of the session. Also, we have a moment where we'll open it up for a lot of questions, either about USC, about Viterbi, or about the department, or about the student experience. So go ahead and make sure that you're putting all your questions in there or saving them to the end, and we'll make sure that we get to those. All right. So let's get started. A few things that we want you to keep in mind during the course of this presentation are a few key points. Like I said, we know that you are in the process of trying to make your decision and trying to see if USC and Viterbi is going to be a great fit. We want you to keep in mind kind of career and academic goals after you graduate and what some of those resources are here within the Viterbi School of Engineering. We also want you to pay attention to the location and some of the access that our students have. Of course, we're going to talk a little bit about our Trojan Network and what benefits come from that. And then also about research opportunities and really some exciting things that are very hands-on that our students at our master's level are able to be a part of and involved in. All right. So, a few facts about the Viterbi School of Engineering. We were founded in 1905. So we've been around for a while, but back in 1905, we weren't known as the Viterbi School of Engineering. We were known as the USC School of Engineering. We were later named the Viterbi School of Engineering in 2004 after Andrew Viterbi, who developed the Viterbi algorithm, which some of you may be familiar with, some of you may not. But for those that aren't, the Viterbi algorithm is an algorithm that allows us all to really communicate on our cell phones without interference from other phones. So very, very vital, key piece of technology and science that we all use every day as we're making calls and texting on our smartphone devices. He also is the founder of Qualcomm Communications, which many of you may know, which is a very, very successful telecommunications business. And so we were named after the Viterbi School, after Andrew Viterbi in 2004. And that's when we became the Viterbi School of Engineering. We are home to 100,000 alumni worldwide. So spread out throughout the world in different countries, domestically in different industries, at different companies. We have a very, very extensive alumni network. We're currently ranked number 20th by US News and World Report. We also are home to a lot of research expenditures, as you can see, nearly 180 million annually. So lots of research happens in all of our departments within the Viterbi School of Engineering. We're home to 213 tenure track faculty professors that are teaching our courses, running our laboratories, and conducting research here within the School of Engineering. We have applicants from all over the world, which also lends to that worldwide network. So over 113 companies. So we have students that come and study and do their master's or their PhD within the School of Engineering from all over the world and many different countries. So we're a very international school. As you can see, we have our breakdown from our gender breakdown, 69% male, 31% female. Most of our students are studying on campus. So we have 83% on campus. That means they're physically here, they're going to classes every day, they're participating in student organizations, they're participating in research, and they're getting involved and physically in classes. 17% of our students are online, and they're a part of our Den at Viterbi online program, which is something to note that our online program is the exact same program you would get on campus. So it's taught by our same professors, same homework assignments, same tests, quizzes, and exams. The only difference is that you can be anywhere in the world and you can be online, or you can be physically here and do it on campus, but it's the exact same class, program, professor work that you would get if you were on campus. So those are just a couple of interesting facts about the Viterbi School of Engineering. So, our proximity. We are located in the heart of Los Angeles. We're about 3 miles away from downtown LA. All right. So, very, very centrally located in the city. Very beautiful campus. We have museums literally right outside of our gates, right outside of our doors, that our students are able to go and take advantage of. Like as I mentioned, we're about 3 miles from downtown LA, so lots of restaurants and concerts and sports events that happen right outside of our doors. Another part that we're really, really close to is Silicon Beach. So we're a few miles away from Silicon Beach, and some of you may be familiar with Silicon Valley. And it's a very similar idea where we have a lot of tech companies in a very small geographic location. And that happens down here in LA, and it's known as Silicon Beach. And so, as you can see, there's a lot of companies that are really, really centrally located on the beach and not too far from our campus. You have Twitter and Snapchat and Facebook and Google and Bird and YouTube and a lot of those different companies that we're all familiar with. And of course, Amazon as well as SpaceX. All right. We also have two institutes right in the heart of this Silicon Beach area that our students are doing research at and they're working at and we're collaborating with that are connected directly to the Viterbi School of Engineering. The first of which is ISI or Information Sciences Institute, and then the second is ICT, Institute for Creative Technologies. So we are very, very hands-on with Silicon Beach. The thing I want to note about this is that these companies have an active role on our campus and recruiting our students for internships, full-time employment offers, and opportunities that our students are able to benefit from just by being in close proximity. It also helps because they're able to come and do workshops or recruit or do very specific tech talks here within the School of Engineering on campus because they're not too far away. And that kind of leads to the next part that I want to discuss, which is our Viterbi Career Connections office. So this is where a lot of those workshops and activities take place. It's through our Viterbi Career Connections office. And this is something that all of our students have access to, both at the undergrad, master's, and PhD level, where they're able to physically go into this office, connect with full-time employees that work specifically on bringing these opportunities to campus. So they work really closely with those companies that I mentioned, as well as lots of others that weren't on that list, to bring them to campus to make sure that you have the opportunity to connect with them. One of the main ways that this happens is through our Viterbi Career Fair. This happens in the fall and in the spring, so it's twice a year. The one in the fall has well over 100 companies that come and recruit our students. So it's a career fair only for Viterbi engineering students, and they're able to network with these different recruiting or hiring managers or recruitment officers at those companies and see what opportunities are available there. So it's an opportunity for you to get some face time with a recruiter at a company, but also really explore to see who's hiring engineers. One of the things that I've always noticed is that many times our engineering students may have one or two companies that they really, really want to work at. They'll go to our career fair and see hundreds of companies that they didn't even know existed or know were hiring engineering students. So it's really an opportunity for you as a current student to explore what opportunities are out there and what that next step is going to look like for you after you graduate. One of the things that we always tell our master students is that this program goes by very, very fast. It's a 2-year program, but literally, when you get here in the fall, you want to start thinking about what you're going to do next summer. What is it going to internship, because many of those opportunities are landed, or you get those opportunities in the fall. So literally you'll be here maybe a month, 2 months before you have the career fair, and you're starting to think about what next summer is going to look like and what opportunities you're going to do hands-on during the summer. And there's a lot of support for you to kind of explore that. As I mentioned, the Viterbi Career Connections office is a physical space, so you're able to go, you can get your resume reviewed, you can have a conversation about how to narrow down your job search. You can access the database to see what companies are hiring for internships and full-time employment offers. So it's really your one-stop shop to really explore this part of your master's journey. And we really encourage all of our students to do so. As I mentioned before, those companies that I talked about in Silicon Beach, they come, they do tech talks, they do networking talks, they talk about how to kind of navigate this part of your journey. As well as our office does a lot of those workshops about, thinking about how to negotiate salary offers, which is something we see a lot of our students go through as they're getting ready to graduate. How can you navigate between two offers, competing offers, and how can you make sure you're getting the best offer for you? So again, this is a great resource for you, and we encourage you to explore it more and more over the next few weeks, which is also leads to my next point. We want you to continue to explore. As I mentioned, this is a really, really crucial time for all of you, and you're thinking about what this journey is going to look like. And the thing that we really want to emphasize is that we want the best option for you and the best fit for you. We know that Viterbi is an amazing place, and it offers a lot of things for our students to do in the classroom as well as outside of the classroom. And now we want you to continue to explore that. One of the ways that you can do that is by attending in-person and virtual events. And you've already kind of checked some of that off your plate because you're here at this workshop, which is a virtual workshop, and we would encourage you to continue to engage with us virtually. There's other opportunities for you to engage with current students over the next few weeks. So keep doing that. We also, if you're able to come to campus, we would encourage you to do so. It's a beautiful campus, beautiful architecture. We would love for you to physically see the spaces that our students are occupying, see the classrooms, see some of the laboratory spaces that our students are currently working in and developing amazing technology. But if you can't get to campus, we encourage you to do a virtual tour and just see what it looks like, what the spaces physically look like, what the campus looks like. That is a very, very important part of this process. We also encourage you to chat with a current student ambassador. We have amazing student ambassadors, one who is on this call, which you'll get a chance to meet a little bit later, that have a wealth of knowledge about what it's like being a current student in the program that you're interested in. So you're going to be able to ask them real-time experience about what it's like on the day-to-day, going to class, being a current Viterbi Master student, and what their experience is like. So continue to do that. All right. And then, of course, learn about all our student organizations and community service and research and everything that we offer here. And we encourage you to do that by scanning the QR code. All right. Lastly, some of the next steps, especially if you're an international student, that we really, really want you to know. To accept your admission, it's important of intent and commitment deposit by the deadline in your USC portal. All right. After you do that, you can then request your I-20 and initiate the visa process. So that's a really, really important part that we want you to start as soon as possible, as we know that there can be delays in that visa process. We want you to also access your pre-orientation resources after you've done that. You can join the Viterbi mentorship program and get paired with a Viterbi mentor. You'll be able to connect directly with your department and your department advisor and get to know some of those next steps in choosing your courses, as well as beginning to explore your housing options and figuring out what that's going to look like as well. All right. All right. So at this point, I'm going to introduce to you some amazing people that I've had the pleasure of working with over the years. The first of which is the department chair for the Mork Family Department of Chemical Engineering and Materials Science, an amazing human being, Dr. Andrea Hodge. And I've got the chance to work with her over the years, and she is a wealth of resource and knowledge, and someone that I hope you get the chance to connect with while you're here at Viterbi. The next person I'm going to introduce to you is our Associate Department Chair for the Mork Family Department of Chemical Engineering and Materials Science, Dr. Noah Momstad, another amazing human being who is a wealth of knowledge that I encourage you to reach out to and connect with while you're here. All right. And then also, I mentioned to you that we have a student here, one of our current student ambassadors, Jonathan Robinson, who is one of our ambassadors. He works with us really closely. He knows a lot of information about the department, about Viterbi, about what it means to be a student here on the day to day, how to navigate it, how to get involved. He is also a wealth of information and knowledge for you as you guys are navigating this process. So start to think about questions that you may have for all of them, and then type those in the chat or get ready to ask those at the end of the workshop. We also are joined by one of our advisors, Zoe Ashmead, who is going to talk to you about choosing your classes, about the curriculum, and what's kind of going to be available for you for that first semester or that first year and what that's going to look like. All right. So at this point, I'm going to pass the presentation over to Dr. Andrea Hodge, who's going to talk to you more about the Mork Family Department of Chemical Engineering and Material Science.
All right, good morning, everybody. So let me share my presentation. And okay, can everybody see it okay?
Yes.
Okay, great. So first of all, again, congratulations. I am currently the department chair of the Moore Family Department. I'm actually a material scientist, but we have both chemical engineering, petroleum engineering, and material science under this department. We are called the Moore Family Department because we are a joint department and we are an endowed department by John Mork and his family. And so that's kind of where you get the MORC, MFD, More Family Department, because it's the three disciplines under one. So what I want to do today is just give you some info about the department specifically, a little glimpse of my research, which is just one of many in the department, and then hopefully encourage you to ask some questions, specifically what it looks like to be a student here in MFD. And then both know I'm a material science, Professor Master is a chemical engineer, so we'll be able to answer pretty much your questions on research, your questions on academics, and specifics like that. The both of us will be able to cover that quite well. So about our department, so we have 24 tenure track faculty. That's people like myself and Professor Malstad. So we're here full time. There's 24 of us. This is a beautiful picture of us. We look really cute. And so this is one of the AICHE conferences. We have 3 full-time teaching faculty, which means they're here all the time. You may or may not take classes with them depending on what your major is. And then we have 1 adjunct faculty who is a technical fellow from the Mars Company who teaches our confectionery class. So what I'm trying to show you here is that your faculty is here full-time. We're around all the time. The 24 tenure track faculty, we do research and teaching, and the teaching faculty, they only do teaching, but just get to see a little bit of that department. So what are research areas and why is this important to you? As Kevin said, goes really quickly, so it's important to know what you're interested in. And so many faculty belong to many of these categories. You can find all this information on our website. So We have five main research areas, which is advancing energy technologies and research utilization. There's many of us under that umbrella. You can see who works on that. Improving health and wellness. So this could be a lot into if you're into more like the biochemical side, vaccine development, disease research, harnessing data science and machine learning. Again, within the context of chemical engineering, material science, or petroleum. So it's not computer science, it's for the use in these specific fields, designing quantum materials and systems and advanced materials and manufacturing methods. So if you go to our website, you can see who fits in there. Why is this important? As you think about where you want to go, what you want to do, kind of like say, this is what I'm interested in, and kind of look which faculty is in a specific category, and then maybe there's a chance for you to talk to them or get involved into research as you look forward for internships in the future. But this, again, it happens quick, so I suggest you do it sooner rather than later, because we end up with a lot of students asking in their last semester, and it's like, we could have, we could have helped you much more if you start earlier to get into the industry that you want. So a little bit about our student population, and this is a picture from about 3 years ago with some of our wonderful master students that were helping us out in the office, and they just used to come and hang out there quite a bit, and some of our faculty here in the back and in the front. So we have about 130 undergraduate students. Our undergraduate population is only in chemical engineering. We have about 90 master students, and that is mostly half and half between material science and chemical engineering, with a sprinkle of petroleum students. Oh, I should say there's also a few energy engineering students which was the program was launched this fall. So yes, and then we have about 115 PhD students. So when you take your master's classes, you have a combination of the master students and the PhD students in the classes, depending on what you're taking inside the department. Of course, there's also electives outside the department, but this gives you a sense that it's a small but yet large enough community that you will find people that you can work with, do projects with, engage with, and challenge you in your classes and to do well. So what are our three master's programs? So the website is currently being updated, but there's only three master's programs that we currently offering. So material science is now material science and engineering is only one. And so we just updated it because it really was a duplicate program. And then this is our standard program in which you have, so if you look in the website, it will tell you the curriculum that it has. It does have lots of flexibility as well if you want to focus more on machine learning, if you want to focus more on the manufacturing side, but it gives you the base background. The students who come into material science and engineering are vary. So this is where we see students more from the sciences and from other engineering fields come in, because material science tends to be more of a professional degree, master's and PhD level. So as long as you have the background in sciences and engineering, then this is where we see a lot of those students come in, which are interested in materials. And since I am a material scientist, I need to do my plug, which is everything is made out of something, and you make it actually in this department, and specifically a material, right? Then we have our master's in chemical engineering. So that just general chemical engineering. Again, for those students that come in there are mostly either from chemistry or chemical engineering. So it's not such a broad pool as a material science students. And you can pick different career paths going from personal care products to food, to energy, to vaccines. So people ask me all the time, students and parents ask me all the time, what is the prospect of chemical engineering as a career and for jobs? And I said, well, when the world stops needing medicine, food, and energy, then you'll be out of a job. But then we will have much larger problem. So this is where it happens. So it's the chemical engineers. So you can thank them for your nice, tasty Diet Coke. Not a plug, they didn't pay me. That's just why I drink. I don't drink coffee. For your vaccines, for your medicine, for your Advil, for your energy processing, whether you're driving a car or you're taking public transportation, these are all processes that chemical engineers take care of. And then, of course, as a joint venture between all the three disciplines, we have our master's in energy engineering. So this launched last fall. We're very proud of this program. It's for those of you who are interested more into specifically energy, learning both about legacy technologies and new technologies. And so this is a perfect program to do this because you have materials expertise, chemical engineering expertise, and petroleum expertise. So people say, well, why petroleum? That's a legacy technology. So any new developments in technology actually launch stuff, current infrastructure, whether you are in the US or any other part of the world, that infrastructure is large and it has been going on for hundreds of years. So this is what you need to learn legacy technologies in order to launch new technologies. So this is what that program entails. And so it talks about, it covers things like solar energy, it covers AI and AI technologies for energy distribution, energy fields, the chemical processes for large energy programs. So this is more of a program for people with a general science degree. The three core classes are designed to give you some background in material science, chemical engineering, and in petroleum engineering. So it's a very unique program, is one of a kind in the country because it focuses actually in the engineering aspect. It's not to make you a manager or something like that, but more a technical leader in energy and energy distribution. And as I said, when the world stops needing energy, then we have a problem. But I think for now, this is pretty secure, and I think this is the new up and coming engineering field, especially with the need of even for AI or anything, for these large infrastructures that require a lot of energy. How do we deal with that? How do we distribute that kind of energy? How do we change the way that energy is distributed or made throughout the world, given different conditions, different climates, different infrastructure, different resources? So this is where that will be at. So I'm very proud of a new program. These are sort of three programs, which I think you will be able to flourish and then really have a valuable degree to help you move forward. In student life, we have different things that happen through the year because that is also important. You cannot just study all the time, but you have to do other things. So we have welcome events, preview week events, a student symposium in which our master students are highly encouraged to participate. So really a place to engage in research, enrich with the community of the MFD, the More Family Department, and be able to be part of the larger community. Because part of the reason you want to come to a place like USC is to build and engage with that network. And you cannot engage with that network or build that network if you stay by yourself. So we have a lot of different events that fit big sizes, smaller sizes, medium sizes, in order for you to find a good fit for something that will work for you. So we have also some student organizations, the Materials Research Society, SPE with the Society of Petroleum Engineers, AKI with the Society of Chemical Engineers, and here's our picture from our board from 2 years ago. They're super active. The Women in Science and Engineering program. So there's different organizations. These are kind of like specific to the field, but there's other many hundreds of organizations at USC that you can join. But this is specifically to the fields in the department, the professional societies if you want to join, if you want, again, building those networks. For example, AKI brings in speakers, recruiters, and although they talk a lot to the undergraduates, sometimes they're also looking for master students. So you make the most out of it by building that network. And the network is expansive, but you have to be an active participant. So a little bit about some innovative curriculum. I really enjoyed this, which is our confectionery class. Why? Because this is for our chemical engineers. Food is a big part actually of chemical engineering. So this is why you can do large production of many consumer products, and why your Diet Coke tastes the same here as it does in Boston. Why Cheetos always so addictive anywhere in the world is because of these chemical processes. And so specifically here, because we hire a PhD senior tech, former tech fellow from the Mars company. So he's teaching more about production and sustainability to making sweet products. And so it's very interesting. Also some connections there if you want to go into the food industry for doing internships at Mars and other similar companies. So very important for you to understand which part of this you want to do. Chemical engineering is so vast that you can pick any of these pockets of things that you're interested in, but they have their fundamentals are in chemical engineering. Of course, we also have a lot of our material science students take this as a materials class. I guess it's a material that you can eat. But it's a fun class. It's once a year, so just kind of giving you a glimpse of it. Um, so a little bit about my research group. This is an older picture. So as I said, my research focuses more in materials. We basically make materials for extreme conditions, specifically for space exploration. So what does that mean? We make windows for the space shuttle, parts for rockets for really high temperatures, extreme environment, materials to protect electronics in space environments. So just a lot of things with radiation, temperature, corrosion. Um, Yes, high impact. And so in my group, we have obviously the core the PhD students, and then we have a few master students here and there, and then a few undergraduate students that work in the group as well. And then they do different types of projects. So I highly encourage you to join or look and search for a group that you can work in, either volunteering or getting paid, depending on the group and what your background skills are. But get that early to help you launch into the internship. Just like a quick side note, last semester I had a student who wanted to go into microelectronics. And he's like, everybody keeps asking if I have sputtering experience, so magnetron sputtering. So he had been here for a year and a half. My group does sputtering. And guess what? He joined the group. He did one semester in the group. He got a job, and this is what he's doing. Even though he was a chemical engineering master student, all the jobs that he wanted to do and what he was interested to do required him to have some knowledge of magnetron sputtering because that's how you code microelectronic devices. And so this is a good opportunity. But again, I would have loved to have him more than just one semester. Um, but this is how you connect to where you want to do in the future industry. And then he started doing that. And about 3 months later, he got a job and then he's out. So, anyway, so a little bit more about the group. We do a lot of work now with machine learning as well in order to do accelerated materials design. This is our work called the Dragons Project. This is sponsored by the National Science Foundation, and we're looking into making the materials much faster, again, for extreme environments, working with basically materials for jet engines. So it's called, so this is just a little bit of how it works. We do the experimental part, and then we work with other colleagues in the department to do the machine learning part. We're an experimental group, and then together we can come up with this accelerated design of new materials. Some of the things that I talked about for extreme environments. So we look at things for radiation damage, neutron shields. So these are multi-layers for that are work for shielding nuclear reactors, for space environments in which you have radiation. We also make windows for, like I said, the space shuttle and rockets and things like that. So they need to be transparent, they need to be strong. So those are some of the things that we work on. And I would love to work on something more like maybe energy efficient windows or things like that. This is what we worked on by doing multi-layer work. Um, Two of my students are currently in charge of one of them is in charge of the Mars Rover Materials Project, working for JPL, and one of them is in charge of the photonics lab that works on the space shuttle. So really cool things that the students get to do. A lot of them go into, like I said, the space industry. Then we're doing a lot of high throughput combinatorial work because very well with machine learning, but this is just specific to my group. I just wanted to give you like a little flavor of what my group does, and then be able to answer, kind of our questions about our department.
All right. Does anybody have any questions? If so, type them in the Q&A chat and we will get to them shortly. All right. And while you guys are thinking of those questions, I will pass it off to Zoe, who is going to lead kind of the next part of our discussion with our student ambassador, Jonathan.
Awesome, thank you. All right, hello everyone. As Kevin mentioned, my name is Zoe. I am the academic advisor for master's students in the Mork Family Department. So I look forward to hopefully working with you all over the next couple of years throughout your journey here at USC. So what we are going to do for the next 25 minutes or so, we are going to have just lots of time for Q&A. I have some questions that I want to ask to our student ambassador here, Jonathan, but we'll also kind of mix this in. If you have questions for Jonathan, for Dr. Hodge, for Dr. Malmstad, for myself, questions, any kind of questions, I would love for you to throw those into the Q&A, and we will bring those questions in as they come in. So do feel free to throw those questions in the Q&A as they come up, and we will answer them as they come up. But while you're getting those questions rolling, I have some questions for Jonathan here that I would love to ask. So Jonathan, would you start out by just introducing yourself and telling us a little bit about your hometown, where you were before USC, and how you arrived at USC and in this degree program?
I'm Jonathan. I did my undergrad in chemical engineering at Long Beach State. I was born in Orange County, and I was raised in Southern California. And so I've always been a fan of USC football team and the school. So that was a big part of why I applied, but also because of their, academic success. I'm currently doing a master's in energy engineering at USC, so the new program, and it's been very interesting to do, and it's been a great program so far, I would say.
Awesome. How did you select energy engineering as the degree that you wanted to pursue?
So for me, I kind of looked at the market. I didn't know exactly what I wanted to do out of undergrad, and so I was looking at, energy is everyone needs energy. It's a growing field, and getting into it early like this and being able to learn specifically about it, like all the like Andrea said, all the new technologies, but also the old technologies, have been really cool to learn about.
Awesome. Thank you. All right, so on that topic, I wonder if you could tell us a little bit about your courses. So, how many courses do you take in a semester? Kind of what's your workload like? What does your kind of semester course load look like?
So for the most part, you'll be in two courses a semester. You'll have one semester with just one course. But overall, the work is manageable. It can be a lot sometimes, deadlines stack occasionally. That's just any part of going to school. But overall, I would say it is manageable. And for my classes specifically, it's different than undergrad, I would say. Here, it's a lot of kind of research projects. You choose what you want to look into, and then you research it, present your project, and that's a lot of your grade for the class versus undergrad, where it's, homework exam, homework exam.
Absolutely. Yeah, the two classes per semester I know is a big change from undergrad. Probably sounds a little weird for a lot of folks, but that two classes fills up your time pretty well.
Yeah. They are 4 unit courses, so you spend a lot of time in the classroom, 4 hours a week or 4 hours per class a week. And then you have a lot of reading usually. You do have some assignments, but they're typically longer and more comprehensive assignments versus, the once a week or twice a week short assignments that you get from undergrad. But it's a lot more project based, I would say.
Absolutely. Yeah. Have there been any classes that have been particular favorites for you?
Ooh, your favorites. I think my CHE 510, which was energy efficiency and design. And that was a very interesting course. It was all about the different kinds of energy production methods. We looked at natural gas, solar, nuclear, um, water and wind, all the different kinds of ways to produce energy. And then we looked into the specifics like efficiency, cost, and carbon savings.
Very interesting. Okay, so we have a question come in from one of our admitted students here. So thank you, Ian. So Jonathan, What is housing like for USC graduate students? Where do you live, and kind of how did you navigate that housing process?
So it kind of depends on your ability to get around. I know international students sometimes have trouble getting cars here. But I would start out living near campus or as close to campus as you can. I personally lived on campus or in off-campus USC housing my first year. And so that was a very simple process. You just apply through the school and they'll give you a few options of what's available. It's harder your first semester because everyone is coming back for the second year, and so they have first choice. But I found that it was pretty simple and easy to get housing, at least from USC itself. And then a lot of students do live off campus, places either along the metro lines, like Culver City is a very popular one. K-Town is very popular. And for that, a lot of students either use Instagram or Facebook groups. They will message students, find roommates, and then decide to either live off campus or continue with their on campus or off campus but USC housing.
Absolutely. Awesome. Thank you. All right, all right. So, going back a little bit to the topic of classes, how big would you say your average class size is for your classes?
So for the master's courses, I found it's between 8 to 12 students in the core classes. Um, in my energy core classes. I think the chemical engineering and the material science classes are a little bit larger in size, but not too big. Um, but it's been nice to be in, smaller classes because it gives you more time talking with the professor. You can ask questions mid-lecture and you're not really taking up too much time. And you kind of get, I think it's a slightly better experience because you're able to communicate more with your professor. If you have questions or if you need help with something, it's been pretty simple for me.
Awesome. Fantastic. Thank you. Okay, so how about outside of classes? Are there any on-campus activities or research or anything that you participate in?
So off campus, a lot of my time is taken up. I was fortunate enough to get an internship, right when starting school. And so that takes up a lot of my time, during the semester. But I have been, my first semester, I was asked to write a research paper by a professor because he just thought it was something I was interested in, and he pushed me to do that. And he said he would support me, and so that was a great option. There are tons of clubs on campus that you can join, all kinds of career events. Those career fairs are really valuable event. I would definitely check those out every time they're putting them on.
Absolutely. And on that topic, I believe you are graduating this semester, is that right?
I am graduating this semester, and everyone that said the time goes by fast is 100% right. It feels like I was just starting this program, and now I only have 1 month left. And so, in that time, I feel like I've done a lot, but I also feel like I could do more. Or I could have done more. And so, definitely do everything you can while you're here. Go to all the events, talk to everybody you can. It's very valuable.
Awesome. And I know this is the question everyone hates coming into their graduation, but do you know what's next for you?
Yeah. Well, I believe I know what's next. I did receive an offer from an automation company that I may be working for, but my current company that I'm still interning for, they are looking to offer me a job, I believe, in the next week or two. So we'll see if that comes to fruition. But I have received offers for when I graduate.
That's so exciting. Congratulations. Hey, multiple offers. That's a pretty good position to be in. So
It's looking
congratulations.
good for me. Yeah. I think we have a question, but I think
Yeah.
Andrea may be more suited to answer that one.
Yeah, absolutely. So we have a question here. Thanks, Michelle. I'm interested in a master's with a thesis in material science. And I saw that a thesis option is not necessarily guaranteed. Could you explain the process of doing a master's thesis? So Dr. Hodge, is that something that you'd like to address?
Sure. So basically, the thesis part depends on you working with a faculty member to specifically work on a research project on that thesis. So that has to be identified, that person of the faculty member needs to identify early. also a match on what the thesis would be. Sometimes the students come with something like, very different from what anybody's doing, then that's really hard. Usually the thesis should match the specific research of the given faculty. And so students will approach the faculty or come to the department chair and say, I'm interested in doing a thesis on this. Who can I talk to about maybe joining their research group? And you have to take some units in that specific group doing research, and how long does it take? So there's also some requirements involved. So if you were going to do a thesis and it involves, let's say, a lot of computational tools, they may have required you to take a specific classes as your electives. So that's why early works, right? The same thing, for example, if somebody wants to do a thesis in an experimental group, in my group, you really will need at least 2 semesters to work on this. So one as a researcher and one as a part of the thesis, because 1 semester is just the training. And so it really, where it says that it's not guaranteed is because it cannot be done just like, oh, I'm doing it this semester and I'm done. Because it has to be something meaningful, something that will lead you into having something specialized and something that you actually learn. And so that's the major issue, is that when students come at the end and say, oh, I want to do this, and then we're not able to accommodate because they didn't take the right electives, or they just don't have any experience at all. And so then the idea is for the class to be meaningful, to the thesis to be meaningful. So you have to know enough. And that really would take at least 2 semesters, I would say, for a minimum. So again, goes quick. It's 2 years. So it needs to be like you need to know it in your first year that you want to do this in order to be a viable option. And that goes for, chemical engineering, material science, or petroleum.
I do want to add to that. When you're trying to go into research, what I've heard from students that were in a course-based master's, and then got into research, you should be reaching out first semester. You should be reaching out the first month that you get there to any research group that you think you may want to work with, and getting all the information you can. And if you do want to research something in their field, I've seen that a lot of times they will try and help you out, but it's all about, like, if your research idea matches the group's research. So, but definitely reach out early, as soon as you can.
Yeah, absolutely. And just a couple of logistical points on the thesis question. So the thesis is not required for any of our programs. All of our programs are thesis optional. So you can choose to complete your program with the thesis, which comes with some additional requirements. So baseline, you will get your degree just by completing the coursework required for your degree, but you can opt into the thesis option, which will add some additional requirements around completing the thesis, including taking at least 2 semesters of thesis coursework, which is really, as Dr. Hodge mentioned, kind of a stand-in in terms of earning units for doing the research and writing the thesis and preparing for the defense. So it definitely is a additional, pretty significant additional set of requirements. So absolutely something that you want to start looking into early. But I will also clarify that you do not have to be pursuing a thesis in order to get involved in research. In fact, I would say the vast majority of students who are doing research with our faculty are not pursuing the thesis an option, which doesn't mean that they're not maybe getting publications or going to conferences or doing other really important, things and getting those really positive outcomes of their research. So thesis is just one option in terms of pursuing research, but it's not the only route or the only kind of way that our students are getting involved in research. All right. All right. So again, please feel free to put those questions in the chat. So I would love to actually pose a question to Dr. Malmstad and Dr. Hodge. We were talking about coursework with Jonathan. Could you tell us a little bit about what course or courses you teach regularly for master students?
Noah, you can go.
Well, okay, so I have not actually. I'm primarily focused on teaching the core undergraduate classes. The undergraduate class that I do teach is fluid mechanics, which is part of the chemical engineering master's curriculum. Our master's curriculum focuses on the core chemical engineering classes, including transport processes, fluid mechanics, reaction kinetics, and thermodynamics. So that's your core. And then beyond that, you have an option to take a variety of electives within the department, spanning the disciplines of chemical engineering, material science, and petroleum engineering.
I teach, not right now because I'm the department chair, but a master's PhD class, which is MAST 551, Mechanical Behavior of Materials. And so that is a class that brings people from civil engineering, mechanical engineering, and from our department. And it is a lecture class, but we also do demonstrations. As part of our materials curriculum, we teach intro to mechanical behavior as an undergraduate class. So we have a really nice lab. So we do get to go there for the students who don't have the background in material science to be able to go see some deformation, some tensile tests, some fracture tests, some Vickers tests as a demonstration as part of the class, but the class itself doesn't have a lab. And so you learn there about fundamentals of dislocations, different types of materials, material synthesis, just more like the mechanical behavior of it. That's usually what I will teach. And again, it's a MS PhD class. And I will say is usually 50-50. But it has students from, like I said, civil and mechanical engineering there as well.
Awesome, thank you. And I am going to put in the chat for everyone our master's advising webpage, which lists out the specific requirements for each of our degree programs. So you've probably already seen this or some version of this in your research looking into grad programs, but if you haven't, I definitely recommend taking a look. You can see the core requirements for each of our degrees along with the courses the degrees that have elective options, the courses that you can take as electives. So definitely a great thing to take a look at to see the types of courses and maybe start thinking about how you might like to put together your specific degree plan. All right, another question that I would like to pose to all three of you actually. Is there any advice or recommendations that you would give for a new master's student coming into Viterbi?
I think really you're always your best advocate. Our students at USC are very well spoken and advocate for themselves. I remember one of our master students, Andrew, who works in our front desk, but also works in Professor Mamsta's group. He literally came the first day, came to the chair's office and said, introduce himself and say, I am really interested in getting the most out of this for these 2 years. This is my first day. How can I meet as many faculty as possible, and how can I get into research? He wasn't quite sure what he wanted to do, and so this was literally the first day, and so it just happens to be we're like, well, our student worker, is not showing up, so we need a new one. This will be a great way to help with our speakers and this and that. It is pay, it's just like 5 hours a week. This will be a good way for you to get to meet everybody. He's like, sign me up. And so we did, and then later on he met more faculty and then he's been doing research. So really be your best advocate and start early. The only thing that I see is just students wait until the last semester, many students. And so it's just really hard to get something substantial, especially at the same time as you're looking for a job. But even one semester before would really help. I was really willing, like, I have students in when we have our social events that come and introduce themselves. And it's like, is it okay if I come just look at your lab and see what you have in there? And so, things like that show some interest. And, the answer has always been absolutely, come check it out. Or students will say, I'm looking for a spot. And I will say, I don't have a spot, but what are you interested in? And they will say synthesis. Okay, then I'll send you to this professor. And I myself introduce them to the other people and say, hey, this is a great student. I'm currently full in my group, but if you're looking for a spot, and most of our faculty do also have master students in their groups, which is really good. And so, but start early. I will say early is the key to get the most out of it. And don't be so worried about is this exactly what I do want to do for my career yet or not? Because if you do it and you don't like it, this is the time to find out. It's during school. Don't do it after you're already working. So it's okay if you think I'm going to do materials and then you're like, no, I really like biotech. That it's okay. Like, but do it early so you have that chance to try it out for at least a semester and see where you really fit in and you're interested in, because that's where you're going to be more successful.
Thank you.
Yeah, I mean, I would agree. You should be proactive about reaching out to people and building your network. If you build your network at USC, that network will reward you for years to come.
Thank you.
I think some of the best advice I could give to students would be attend all the events you can, um, especially if you are looking for a job right after this and you want to stay in Southern California. Go into the how to get hired, mock interviews, resume review, and then finally the, career fairs. You're going to be speaking with recruiters, hiring managers, and people that are in the industry and getting to know them. And so when you're, applying for your jobs or trying to get an internship, you'll have people to reach out to and maybe refer you or give you the best advice on how to get hired at a specific place you want to work at. That's the number one advice is just talk to people while you can at USC and specifically with the Trojan Network. If they also went to USC, they'll want to give you a shot. They'll want to give you an interview and just see how you perform.
Absolutely. Absolutely. Thank you. All right, we have just a couple minutes left, so if anyone has any last questions, go ahead and throw them in the chat. If not, if anyone has any of anyone here has any kind of last thoughts or last words for our admitted students today.
I really think what I see that the students that are most successful in the master's program are students that are here to challenge themselves. Sometimes you hear students go, which is the easiest class? That's not the mentality. It really is to like, what are you want to do? What are you want to learn? And like something that will expand your knowledge base. So you have your undergraduate degree, you expand in this. So it's not about the easiest class, it's about something that will challenge you. So we really recommend that you go with something that um, maybe has a lab or maybe a class of something that will expand your current skills. So if you're a chemical engineering student, it would be great to take a material science class. If you're a material science master student, it will be great for you to take maybe an energy class from one of the chemistry faculty, really expanding, because what the companies are looking for when you work in these multidisciplinary teams is that you have a really good solid foundation and knowledge base. So we engineers, we're about solving problems, we work with teams. So that would be my recommendation, to really look, when you look at that curriculum, is what will give me, you're paying a lot of money to get a master's degree, get the most out of it. There's some classes that will really be useful for life for any field that you go into. And so don't be scared because they may look a little harder. Like those classes will make you grow the most. And then of course there's other classes like our confectionery class that has a lot of chemistry, but at the same time, is something specific to the field of food industry. So it just depends what your interests are, but really look at those classes as a foundation, not just like two. You know, that's really not doing good service to yourself. The classes are much more than that, and the depth of the classes and how you want to take those electives. Obviously, there's the core, and then there's the electives. That's when you really could enrich. All of our students, we have plenty of machine learning and AI classes. You had to take at least one of them. It's like basic Spanish. You had to do it now. It doesn't mean you're a computer scientist, but you better be familiar with it. That's specifically in the field that you're in. So I'll encourage that. We have several classes from 400 level to 500 level to take at least one of those in the electives. That's what I will encourage the students to do. It's about being well-rounded and being the person that a company wants to hire, because you have all the tools and skills and mindset that shows that you're really willing to put the time and effort to be the best engineer that you can be.
I do want to add real quick. I am in two their material science 515 and 520. They are AI and chemical engineering, machine and material science, and then one's mathematical models for deep learning. And I'm not a computer scientist. I don't know how to code very well. I'm proficient, but doing those courses so far has increased my coding skills, my understanding of AI machine learning. They've been great resources on, learning this new frontier of technology that I think is going to be valuable for the future. So that's why I'm taking them.
Awesome. Thank you.
All right. This has been great. Very, very informative. I'd like to take a moment and thank Dr. Hodge, Dr. Malmstad, Zoe, Jonathan for joining us and lending their expertise and knowledge in the program and in the experience that you guys are going to all have as incoming Viterbi students. Once again, congratulations. And if you have any questions, feel free to reach out to us directly or go back and visit some of those links or QR codes that we mentioned before, and continue to explore and continue to see if this is going to be the place for you. And we hope it is, and we hope to see you in the fall. Thank you, everyone. Fight on.
Bye bye.
Bye bye.